Welcome back to another Shouting Electronics. On the workbench today we've got another air conditioner control board. This I believe is from a Galanz air conditioner that's not running. I told somebody I'd take a quick look at it and see if it's a quick thing to sort out. First let's take a look at the fuse, obviously. Of course, without the rest of the air conditioner it's very difficult to test this. So I'm just going to do a quick repair, give it to them and let them take a look, see if it works. Okay, now the label on the board here says, it says fuse is 3.15 amps to 50 volts AC. If you take a look at the fuse, that is a very thick blade. And if we're reading the rating over here, don't know if you can see it, but it is a 20 amp fuse. Okay, now I don't have a 3.15 amp fuse on me, so I'm just going to put an 8 amp fuse with a note for them to get the correct fuse. And just another thing that they did notice and inform me about, that there is a component missing over there. If I look at the designation, it's a capacitor 21104, which is a 104 is a 100 nanofarad or a 0.1 microfarad decoupling cap for the ULN Darlington array, and that is your main processor chip there. Okay, so straight away you can see that burnt section over there, which is straight after the fuse, so it looks like it could be the live in comes from this side, maybe through that relay on top of the board there. Comes through, goes through there, and then goes through all the driving relays and through a nice little solid state relay board there, the AQH 2223. It comes with free ants. I don't know if you can see that there above my thumbnail. But let's clean up this section and see what we are dealing with here. Looks like we also had some tracking across to over there that's carbonized that, so we'll have to remove that bit of carbon, and then maybe we can just fix up this little section and then change the capacitor, and that should be golden. Once we're done, we'll just give it a good coating of conformal spray, just to make sure we don't have any tracking over the top as well. Okay, let's do a check now. Got my multimeter here on continuity test, which is a beep beep. So fuse to there, fuse to there. That actually looks okay. Outside of the fuse. Okay, doesn't look like we've got any continuity across there, so I think as a test I'm just going to go reinforce this section over here. Just give it a nice little bridge of wire, and then we carry on from there. So this being thicker wire is more than capable of 3.15 amps. Okay, so I've got my probe held onto the one contact here, which I believe is the live in. If I go underneath, look, there's the coil inputs to that relay. So this should be, yep, that's a pass through from the top, so the live definitely goes in there, up, up, and it's traveling all the way to there. I think it might have been arcing over to there, which could be the problem, because that is your neutral section. So it could be there's a slight breakdown here caused by moisture or something that was causing tracking and blowing the fuse maybe. Okay, so now we should just need to change the capacitor, give it a quick scrub up and formal coating, and then that should be it. So let's change this capacitor. Which is right next to the Darlington array, so it's a very good place to keep it. Don't we need a solar sucker, or do I? Ah, yeah, I do. Okay, now, choice of having spare boards. Here's one I prepared earlier. There was a pull. It's got a bit of extra solder on the leg, just for fun. This board actually looks in good condition, so I hope it was just the tracking issue that blew that fuse. And then they went and put in a bigger fuse, which allowed it to track more. Not these legs are spaced very far apart, but they are through enough. Try and get this solder job in the shot. Now you can't really see the legs poking through. They are there. Just heat it up, give it a bit more of a push from the back with my finger. And that's in place. Okay. Okay, so now we've replaced this faulty capacitor over here. We have checked that we do have continuity from the input terminal on top of the relay all the way through to all those relays, which we had that before, but we did have this tracking across to the neutral section on the board. Okay, so while we've got this unit on the bench, let's just go through a bit of the connections and how the path generally works. We've already said your live comes in on the relay over here. This takes live out to the outdoor unit to run your compressor and your outside fan, because that is normally a high current draw. You don't want all that current passing through the traces on the PC board, so they just do that. Then from there it goes through a fuse and through these relays out to the hot and the W outputs on top here. Okay, we also go, after the fuse, we also go out to the transformer. Okay, transformer's signal, or transformer's output, comes back down here to the power supply section, which runs through a 7805 voltage regulator and powers the logic side of the board. We've got inputs for temperature probes or pressure sensors over here, conveniently color-coded. On the top, we got a connector for a stepper motor, I believe. That's for that fan that controls the louver inside. Got a connector for the display and a connector for PG. I don't know, pretty good connector, who knows. Okay, then we also got two little switch 1 and switch 2, and that's basically about it. There is a nice little solid state relay over here with an ant on it. It's actually got a very funny layout to it, you see here? That's what made me actually Google this part specifically, because it's got, okay, the part is a AQH2223, 1, 2, 3, 4 pins, okay, 5, 6, 7 is missing, and then we got number 8. If we look on the back, pin 1's not connected, we've got pin 2 connected, pin 4 connected, pin 5 is doing nothing, pin 6 goes out, and pin 8. Okay, so pin 8 brings your live in. It gets switched, goes through a coil, which you can see over there, which then goes to your fan control. Okay, so that's your fan control. That's your fan in the indoor units. It's also got a nice, funky looking capacitor over here. Don't know if you can see that. Capacitor for fan motor 1. It's got 1.5, 2 microfarad, 450 volts. There's two capacitors built into one to control the fan speed, and it works together with this handy little solid state relay. Okay, so that's basically all I can do with this board, because I don't have the transformer, I don't have the rest of the unit, I don't have probes, the thing doesn't have any LEDs on it to show power good or anything like that, so I'm just relying on what I've tested. I'm going to give it a spray of conformal coating, just clean up the board a bit, and then give it back to them and let them test it out. Hopefully it works. Thanks for watching. If you like this video, give it a thumbs up and click that little bell icon if you want to be notified whenever we upload a new video.